Hi students, this is going to be a little bit of an algebra review on solving quadratic equations. We're going to use the same equation and we're going to solve it with two different methods. We should get the exact same answer, whichever method we choose. So let's go ahead and take a look at the equation. So the equation is 0 equals 3x squared minus 18x plus 5. So we first have to identify that we have a quadratic equation. And that is if I have a degree equal to 2. And that we see is the highest exponent on our variable. Okay. So the first way we're going to solve this is going to be with the quadratic formula. We can actually derive this formula, but for now we're just going to go ahead and use it, but there is a method to why we're able to use this. It's not just some trick that we regurgitate. So x equals the opposite of the b value plus or minus the square root of b squared minus 4ac, this entire side over 2a. Now when we look at this original equation, this is my a value, my b value, my c value. If there is no b or c term, if we don't have an x term or a constant, the b or c would just be equal to 0. If we don't have an x squared term, we don't have a quadratic equation, so that we won't be dealing with. We always want to make sure we say what are we solving for. We're solving in this case for the variable x. And please notice that we start in general form. Okay, which means we have the highest exponent on the variable, then the exponent that comes next to the first, and then the constant. All right, let's go ahead and plug in our values. So let's write down a is 3, b is negative 18, and c is 5. So we say the opposite of negative 18 plus or minus the b value, and notice I'm putting these parentheses. It's very important that you do that or you will get a different answer. Minus 4, that's part of the formula, times the a value times the c value, all over 2 times a. All right, let's see what we get. The opposite of negative 18 is 18. Then we'll have our 18 squared, the opposite of 18 squared, which is a positive 324. Minus, we'll have minus 60, and that's all over 6. So we'll have plus or minus the square root of 264 divided by 6. Now we want to see if this square root comes out nicely. And unfortunately, it does not come out nicely. So we could go ahead and simplify this radical. But at this point, I think we'll leave it as is. Maybe I'll show you how to do that at the end. I might show you at that. For now, we're just going to go ahead and split the fraction because I do see that we can go ahead and do that split and clean at least a little bit up. So we'd have 18/6 plus or minus the square root of 264 over 6. And so we would get 3 plus or minus the square root of 264 over 6. If we wanted a decimal approximation, we would say 3 plus the square root of 264 and that was divided by 6. So we should get approximately 5.708, and then x would be also approximately equal to the difference of those. So we could do the same thing but with a minus sign, and there we would get about 0.92 if we rounded. So those would be the two values. Now if you wanted to check this, on Desmos or with your graphing calculator, so you could say to check write original as a function. So we would say y equals, instead of 0 equals, y equals 3x squared minus 18x plus 5. And then you're going to identify the x-intercepts. And you should see these two values on the x-axis. So there's lots of ways to be able to verify that what you're doing is giving you that correct answer. Okay, so the next thing we're going to do is we are going to complete the square. So you're going to write down that equation again. So let's see here. We'll have 0 equals 3x squared minus 18x plus 5. Okay. And so to complete the square, we're going to go ahead and make sure again, is it in general form? Yes. We're going to look at the x terms and we are going to take out anything that is a leading coefficient that's not 1. So minus 6x, and then we leave our space like we normally have. Space here and here. Okay. So now we need to go ahead and complete the square. So for this one, we can do our little area model, and we have an x squared, and we know this has to be negative 6x, so we just cut it in half. And we've been completing the square for a while now, same idea. And the big thing is, what is this missing piece? In this case, it is positive 9. So I will write plus 9, but I didn't really add 9. I really added 27. So I am going to subtract 27. Okay, so let's go ahead and rewrite this. So 0 equals 3 times x minus 3 quantity squared minus 22. Now, the directions on here are to solve the quadratic equation. So we need to solve for x. We need this to get x completely alone. Well, I see right now that that x is trapped in this perfect square. If we expand it, we're just going back to where we were in the previous line. We don't want to do that. What I would love to do is isolate the squared term, isolate this whole thing. So I am going to add 22 to both sides. 22 equals 3 times the quantity x minus 3 squared. And now again, I still want to get that x minus 3 quantity squared alone, because then I can undo by taking the square root. So let's divide by 3 first. Now this does not come out nice, which is okay, no worries. And we have x minus 3 quantity squared. Okay, now from here, how do I undo a perfect square? I take the square root. And of course, I remember we need a plus minus. So x minus 3 equals plus or minus the square root of 22 thirds. I will add 3 to both sides. And I'll get 3 plus or minus the square root of 22 thirds, and that is equal to x. Now we have done rationalizing the denominator. So I will say at this point, you know how to write this. We would say that we're going to multiply by the square root of 3 over the square root of 3. We know not to leave a radical in the denominator. So that's 3 plus or minus the square root of 66 over 3. And remember, the square root of 3 times the square root of 3 is the square root of 9, which is a perfect square. So we just put that 3 on the outside. Now let's see what x is approximately equal to. So we'd have the square root of 66, and we're going to divide that by 3. And then we'll add 3, which is approximately 5.708. And let's go ahead and do the subtraction. So we'll do 3 minus the square root of 66. divided by 3, and we get approximately 0.292. And we have the same answer as when we did the quadratic formula. Now, this original was not able to be factored. If you were able to factor this, all three methods would give you the same exact answer. So it's really up to you. There's times where you'll be asked to show a skill, and there's times where it just says solve. Once you know it's a quadratic equation, you can certainly use solve by factoring. You can solve by completing the square first and then isolating that squared term, or you can do the quadratic formula.